Hello, lovers of Mathemasoft. I'm welcoming you to another class. And today we'll be solving some past questions on indices just to step up our knowledge in the indices class that we've been having. So today we have 4 questions on the board, and these are 4 questions actually based on indices question leading to equation. In the last class, we had some questions that were basically expressions, and the only thing we did to those questions was to simplify them. But today, we have equations, indices, equations that we need to find answers to some variables stated. So let's dive into question 1. Question 1, we have 270 equals 2 times 3 raised per n times 5, and they ask us to find the value of n. So in this equation, I can observe that I have this as an ordinary number, ordinary number, ordinary number. This is the only one that is an index, that is written in index form. So I can say, still retain my 270 here. Let this number multiply this number 2 times 5 times 3 raised per n. Then I can say I have 270 equals 2 times 5 will give me 10 times 3 raised per n. Of course, I cannot multiply this 10 by this 3 raised per n because they are not of the same term. This is raised to power n, this is not raised to power any n. Okay, so this is ordinary number, but this is not just an ordinary number. So it's having a power, and the power is even an unknown as such. So it's not the same term. I cannot multiply them. So what I need to do next is to divide both sides by 10 so that I can remove this 10. Divide both sides by 10. So I will have 270 over 10 equals 10 times 3 raised per n over 10. And then I can say 10 cancel 10 and 0 cancel 0 here. So that will leave me with 27 equals 3 raised per n. Okay. 3 raised per n. 3 is already the in its own simplest index form. But 27 can be expressed as what? Power of 3. That would be 3 raised per 3 equals 3 raised per n. Of course, you know that 3 times 3 times 3 will give me 27. That's why it is raised per 3. So I can compare these two sides now. We are comparing. When you get here, don't say 3 here, 3 here. No, that is not correct in mathematics. What you can do is just to compare the two sides. If this base number are equal, this is 3, this is 3, therefore the power should be equal. So we can say n equals to what? Equals to 3. And that will be our final answer. Our n in number 1 is equals what? 3. I hope you understand that. So let's move to question number 2. Okay. In question number 2, we are given this equation, and we have to express n in terms of x and y. We need to first understand this. It means that in our final answer, x and y should appear in our final answer. It is n that we want to find, but when we are finding our n, let us bear in mind that the answer of our n will contain x and y. So you don't have to stress yourself. So we write the question, the equation rather, root 3 raised per n equals 3 raised per x over 27 raised per y. So, and then I know that I can rewrite this as 3 raised per 1 over 2. Okay, and there is n there before, that will be raised per n, and then I have 3 raised per x. This 27 also can be written as what? Power of 3. So that will be 3 raised per 3, which is 27, bracket, I have y there before, I put my y. Of course, you remember that in the law of indices, if I have 3 raised power 1 over 2, it will become square root of what? Of 3. So you can always go back and forth like that. So now I can say that this will give me 3 half times n will give me n over 2. And then I will have on this side now 3 raised power x. This line here means divided by, and this is 3 times y. That will be 3 raised power 3y. So the next thing is for me to say 3 raised power n over 2 equals, here is already looking like a law in indices, okay? So I can pick 3. I have what? X. This division line will become minus, and then I will have what? 3y. The same thing we did in number 1. We can compare the two sides. Don't say 3 cut 3. 3 does not cut 3. You don't have any proof for that. But because the base is the same, so we can compare the power also. That means that what? N over 2 equals x minus 3y. So for us to remove these two now so that we can get our what? N, I can multiply both sides by 2. I will multiply both sides by 2. So if I say 2n over 2 times 2 equals 2 bracket x minus 3y. Okay, or if you like, you can write the 2 first. Anyone, you still get your answer. Let me write that so that we can be in order. So 2 multiply this, and 2 also multiply this. Of course, because this is an expression, so I have to put that 2 so that it will be in bracket. This 2 is affecting all of them. It's not just for x. So 2 cancel 2 here. My final answer, n equals 2 bracket x minus 3y. You don't need to use 2 to open the bracket. Just write it in the factorized form like this. So it shows that you have factorized it down. So you don't need to be saying 2x minus 6y. So this is okay. But if you're writing objective examination like JAMB, you can check the option. If the option is still left in the form 2 times x, 2 times minus 3y, if it's left like that, so if you get it in the option, you can actually choose that. But if you're writing theory, this is fine. I hope you understand that. So it's a soft work. So that would be the value of our n. So you can see in the final answer that I wrote that what my x and y actually appear according to what they told us, that what the answer should contain what x and y. So the answer contains what x and y. So number 3 now. Moving on to number 3. Number 3, we are to solve this. Such a simple question. Solve this equals this. So I have 5 times 8 raised by 3n plus 1 equals 80. Okay. So this is ordinary number. This is ordinary number. So if you observe that, so we can divide both sides by 5, so that we can remove this 5. Divide both sides by 5. That will be 5 times 8, 3n plus 1 divided by 5 equals 80 divided by 5. 5 will cancel 5. Okay, that will give me 8 raised by 3n plus 1 equals, this will give me 6. That will be 16. So by observation, okay, when you look at this, 8 can be expressed as the power of 2, and 16 can be expressed as the power of 2 also. So that makes us to be thinking about something having the same base so that we can compare the power. So let's do that. So 8 is 2 raised power 3. Okay. Bracket what is here before? 3n plus 1 equals, this 16 is 2 raised power 4. Okay. When you multiply 2 in 4 places, you get 16. When you multiply 2 in 3 places, 3 times, you get 8. So that's correct. So now that the base that I have on both sides are the same, I can compare the power. So the power also 3n plus 1 equals 4. Okay, so that will give me 9n plus 3 equals 4. So let's subtract 3 from both sides so that I can remove this 3. So that will give me 9n plus 3 minus 3, the 3 I want to remove, 4 minus 3. And that will give us, this we cancel out, that will be 9n equals 1. So the next thing is what? Divide both sides by what? By 9. Divide both sides by 9. So our answer will be 9n divided by 9 equals 1 over 9. 9 cancel 9. Therefore, n equals 1 over 9. I hope you can see that. So you take it step by step, applying the laws of what? Indices. So applying the laws of indices, breaking big numbers down to index form, and then you begin to have it what? Simplified. So our n equals 1 over 9. Okay, you can always test. If you want to check, you can always test if you are correct. Like this one, I'm interested in this. Let's see. Let's test this. Let's cross check it if it's correct or not. Okay, let's cross check if it's correct or not. You know, this is the equation that we are given. So let's see if the left hand side will be equal to the right hand side. So 5 times 8, 3. What's our hand that we get as our hand? We got 1 over 9 plus 1, then equals to 80. So let's concentrate on this side and see if we are going to get 80. 5 times 8, 3, here 1, 3 in 9. That's 3. That will be 1 over 3 plus 1 equals 80. Okay, so I will have 5 times 1 over 3 plus 1. Okay, that will be 8. LCM will be 3. Okay, that will be 1 plus 3 equals 80. That will be 5 times 8, 4 over 3 equals 80. And that will give me 5 times 8 can be written as 2 raised to power 3 with 4 over 3 that is here before. That's 4 over 3 equals 80. And that will be 5 times 3 will cancel this 3. 2 raised to power 4 equals 80. What is 2 raised to power 4? 2 raised to power 4 is 16 equals 80. And 5 times 16, 80 equals 80. Balanced. So you can see, so it's balanced. It means that the value that we got for n as 1 over 9 is correct. So that's just for us to cross-check. That's how you can always cross-check if you are doubting your answer. Okay, but if you follow the rule, definitely you should be sure that what your answer that you have gotten is correct. Okay, yes, I'm excited. We are in number 4. Okay, number 4. Find n if x raised to power 3n minus 2 equals x raised to power 8 into bracket raised to power 3 all over x squared. So let's take that. X 3n minus 2 bracket x raised to power 8, okay, raised to power 3 over, okay, x squared. All right. So the first thing, let me concentrate on this side. This side is already settled. So this side, I'm having x raised to power 8 times 3, that will be 24. This line divided by x raised to power 2. So x raised to power 3n minus 2 equals x raised to power 24 minus 2. X raised to power 3n minus 2 equals x raised to power 22. So let's compare the two sides. Comparing the two sides now, x. So the power also can be compared. That's 3n minus 2 equals 22. Add 2 to both sides, add 2 to both sides. So that I can remove this minus 2. That will be 3n minus 2 plus 2 equals to 22 plus 2. That this will cancel out. Then 3n equals to 24. Divide both sides by 3. Divide both sides by 3. That will be 3n over 3 equals 24 over 3. N cancel, 3 cancel 3. Okay, and then now we have n left here equals 24 divided by 3. That will give me 8. Therefore, my n is equals to 8. And we have come to the end of the solution to the 4 indices questions that we have on the board. And these are past questions. You can try to scan through again, watch the video over and over again for you to understand what we have done. If you have missed some previous classes we've had on indices, do check through the modules I've dropped on indices in previous classes. Check those classes, try to understand what we did in those classes, and then you can come back to this video and you will see that it will become simple for you to assimilate. Share this video with students around you, and do subscribe and turn on the notification button so that you can always get notified anytime I drop a new video. My name is Mr. Legend, and I'm here to assist you get that excellent performance in your mathematics examination. God bless you, and see you in another class. Bye for now.